Hello everyone! Today we're going to cover 9.4b, which is an extension of what we did yesterday in 9.4a. We're still going to be solving quadratic equations using square roots. All right, so how is what we're doing today any different than what we were doing yesterday? Well, what we were doing yesterday is we would start with an equation like x squared equals 9, or we might even make it more complicated than that, but eventually it would get to this point, and we would be able to take the square root of both sides and know that x is equal to 3. But we also learned that 3 is not the only answer here, because x equals -3 would also work, because when I square a positive, it gives me a positive, and when I square a negative, it gives me a positive. So we're always going to end up with two solutions to these equations. What we're doing today is extremely similar. It's just you'll notice we have parentheses in this problem, and we have x plus 1 inside the parentheses. The idea is still the same. We're trying to figure out what value of x we can put here that would make the whole equation equal to 9. We're still going to get two solutions because when I square something, I always get a positive answer. But what's different is we have to deal with this plus 1 that's inside the parentheses versus being outside the parentheses. Some people's initial thoughts are, oh, well, let's distribute that power of 2 and that will help us and it will make it easier. We can't do that. If we wanted to get rid of the square in a way that we already knew, we could multiply x plus 1 times x plus 1. And then we would be able to use a different method. But that actually is going to take us a lot longer, especially when we know that when I take the square root of something that is squared, it cancels it out. So when I square root this, I am left with x plus 1 equals the square root of 9. Okay, and I've already gotten rid of the squared. Now you might be thinking, oh, that's simple, right? Because the square root of 9 is 3. But just like in the last problem, we are always going to end up with two solutions. We're going to have one of them that's equal to a positive 3 and one that's equal to a negative 3. And from there, we're just going to have to continue solving to figure out that x is either 2 or x is either negative 4. Now, how this works when we look at the original equation is if I were to plug in, a 2 for x, what I end up getting is 2 plus 1, which is 3 squared, and that's 9. If I plug in a -4, -4 plus 1 is -3, and -3 squared is 9. So we're just figuring out the values that would make that binomial a positive 3 or a -3. So it's very similar to what we did yesterday. It's just going to be a little bit more complicated at the end. Now you might notice that my writing or my format here is a little bit different. I am having to record this on my iPad because it doesn't work on my computer for some reason. So I apologize. All right, so we're going to get into the notes and start taking some notes here. So make sure you have your 9.4b note packet open. The first thing in this process is we are going to have to isolate the binomial squared. Binomial. If you remember, a binomial is something that has two terms in it. So we are going to have to get that all by itself. Let's look at a problem as we are talking through these steps. So negative x plus 2 squared plus 4 equals negative 60. All right, so in this problem, if I want to isolate the binomial squared, I need to get rid of anything that is outside of those parentheses. And just like yesterday, we are going to add or subtract first if it is possible. So that leaves me with negative x plus 2 squared, because the 4's cancel, equals negative 64. Now the number in front of the parentheses is -1. So we can now divide both sides by -1 in order to leave us with just x plus 2 squared equals a positive 64. As a reminder, if you need to pause this video at any point in time, you can. Now we have that binomial isolated. It's all by itself. There's nothing outside of those parentheses. So we can take the square root of both sides. And what that's going to do is it's going to cancel out that squared and leave us with something that doesn't have a power of 2 in it. What we're going to think about at this point is we are going to think about those two solutions. One of them is going to be equal to a positive answer, and one of them is going to be equal to a negative answer. So on this side, I have just x plus 2 that's going to be left. So I'm going to have x plus 2 equals positive square root of 64. My other solution is x plus 2, but this time it could be equal to the negative square root of 64. So I'm just making one of my answers positive and one of my answers negative. From there, we have a couple different options, but I'm going to recommend that you try to simplify if possible. So let's think about the square root of 64. First and foremost, I hope you know this one because it's a perfect square root, but the square root of 64 is 8 times 8. So the square root of 64 can be written as 8. That means on the other side, we would have x plus 2 equals negative 8. And then from there, our very last step is that we can finish solving for x. So I need to get x by itself in both of these equations, which means I have to subtract 2 in both. Now be careful, because a lot of people have a tendency to say that one of my answers is 6, so the other one must be negative 6. But we already took care of that piece, and we just need to follow the actual process here, because we are going to get 2 completely different answers. The other answer is negative 10 when I end up subtracting 2. So be very careful with how you find your solutions. Now, we're going to do another example, and this second example is a little bit more complicated, but I know you can handle it. So our second example is x plus 3 squared minus 4 equals 11. So step 1 is to isolate the binomial squared. So we are going to work on getting this x plus 3 squared all by itself. The only thing that we need to get rid of in this problem is that plus 4. Or sorry, that minus 4, so we plus 4. That leaves us with that binomial on the side by itself. Step 2 is we are going to take the square root of both sides. We are going to do that so that we can cancel out this power of 2. That leaves us with just x plus 3 on that side with no more squared. When we do that, we will always get 2 solutions, one of them equal to the positive and one of them equal to the negative. So we have square root of 15 and negative square root of 15. Next, we are going to think about simplifying our equation or our square root. So let's think about 15. 15 is 5 times 3. There are no pairs when we are trying to simplify that. So unfortunately, this one we just leave as x plus 3 equals the square root of 15, and x plus 3 equals the negative square root of 15. But we are not done, because we don't want an answer for x plus 3. We want an answer for x. So the very last step is we are going to work on getting x by itself. So we have to subtract 3 from both sides. This is where things get really awkward, because we are going to have to write a very icky answer that no one really likes to write, but it just is what it is. We cannot combine together these two terms. We have something that has a square root and something does not. Also, make note, these are not multiplying with each other. They are subtracting and adding with each other. The traditional way of writing this is to write that negative 3 first and then plus the square root of 15. That would be the way you would see it probably in a textbook. However, it is absolutely okay to write the square root of 15 first and then put that minus 3 at the end. Likewise, in the other equation, when we subtract 3, we are going to be left with either negative 3 minus the square root of 15. That is the more traditional way of writing an answer. Or we can write negative square root of 15 minus 3, and that works just the same. So when you are left with a square root that you can't get a perfect answer for, you're going to be left with kind of an icky answer, and that's okay. All right, the next one we're going to do is a try this, and I'm going to walk through it with you one more time, and then I'm going to have you try a couple on your own by answering questions through Edpuzzle. All right, so the first thing we have to do is we have to isolate that binomial squared. This time, we have to divide both sides by that number in front. That leaves us with x minus 2 squared equals 12. Because we have it by itself, we now get to take the square root of both sides, which is going to leave us with x minus 2 either equal to a positive square root of 12 or x minus 2 equals a negative square root of 12. We're going to try to simplify the square root of 12. It's not a perfect square root, unfortunately, but we can break these numbers down and we can see that we have a pair of 2's. So the square root of 12 could be written as 2 square root of 3. So that means on the other side, x minus 2, we have negative 2 square root of 3. Now, if this was yesterday, we would be done, but it's not yesterday. We are going to solve both of these equations for x. So we're going to add 2 to both sides and write our answer. And it's going to be an icky answer because we're left with a square root over there. We didn't simplify it all the way to a regular number. So the traditional way of writing our answer would be 2 plus 2 square roots of 3. But you could also reverse those and say 2 square roots of 3 plus 2. That is also completely fine. Those are exactly the same. On the other side, we will have x equals 2 minus 2 square roots of 3. Or we will be left with x equals negative 2 square root of 3 plus 2. Either one works just fine for me. All right, so now that you have your notes filled out, what you're going to do when you finish this Edpuzzle is just 2 more problems, and I'm going to work through them, but I'm going to ask you questions occasionally as you go. So here is the first one. We have 2 times x plus 4 squared minus 7. All right, let's try one more. Now remember, there are two other ways to write these solutions, so if you wrote them the opposite direction, that's absolutely fine. I hope you have a great day. Work on your practice worksheet. Bye!